Three different publishers will tell you this model refuses nothing. 0 refusals, 0%, 0 out of 100. And one of them ships the file that proves what that number actually measured, which is not what you think and not what anyone quoting it thinks either. The question I started with was narrow and practical. Is there an obliterated build of Qwen 3.8 27BA, a version with the refusal behavior stripped out, that will actually run on oMLX on a Mac? That is a yes or no question with a yes or no answer. What I did not expect was that answering it would take about 90 seconds, and that checking the evidence people offer for it would take the rest of the afternoon and turn up 5 separate things that are wrong. First, what the technique is, because the word gets used loosely. Obliteration is not a jailbreak and it is not a system prompt, it is a weight edit. You find the direction inside the model's residual stream that corresponds to refusing, and then you project that direction out of the weight matrices that write into the stream. The distinction matters. The model does not decide to stop refusing, and it is not being tricked into complying. The machinery it used to refuse is simply no longer present in the weights. That is a permanent structural change to the file on disk. Most releases describe this in a paragraph. One of them, Pocket Ahab, ships it as a machine-readable manifest sitting next to the weights, and that changes what is possible. You cannot audit a sentence, but you can audit a sentence, but you can audit a JSON object. The manifest pins the base model to an exact Git revision. It says the refusal direction was read from layer 53 of 64 and projected out of layers 24 through 63. And it names 3 kinds of weight matrix, one of which tells you the author knew what they were editing, linear attention output. This model interleaves 48 linear attention blocks with 16 full attention ones. An ablation that only handled full attention would leave 3/4 of the blocks writing the refusal direction straight back in. So, the answer to the original question, yes, take the Orcar-Bowder build, the 6-bit folder, 21.24 GB on disk. It has 47,000 downloads against the alternative's 0, which means other people have hit its problems before you will. And it ships something the alternative does not, a separate MTP drafter for speculative decoding. That part is not in dispute, and I want to be clear about it up front, because everything I'm about to say is about the evidence offered for that recommendation, not about the recommendation itself. Here is where it gets expensive. The model card tells you what you need, mlx version 0.32 or better, and mlx-vlm 0.6.13 or better. So I looked at what oMLX actually bundles inside its app bundle. mlx 0.32, that passes. mlx-vlm 0.32, that passes. mlx-vlm 0.6.3. 10 patch releases short of the stated requirement. On the version numbers alone, this machine fails. A reader who stops there downloads nothing, installs nothing, and concludes the whole thing is a dead end. And that reader is wrong, because the version string and the capability stop tracking each other. The thing that actually determines whether the model loads is whether the runtime has an implementation for this architecture, and it does. 3,600 lines of it across 4 files, including the gated DeltaNet kernel that the hybrid attention depends on. That is a full port, not a name in a dictionary. The speculative decoding drafter is in there as well, and registered in the drafter table. The reason is simple. oMLX does not ship stock mlx-vlm. It carries its own patch tree and ships model support ahead of the upstream release. It is numbered after. The version number names the base it forked from. It is not a statement about which architectures it knows. Static inspection tells you a module exists. It does not tell you the weights load under it. So I pulled the 6-bit build and the drafter 22 GB and ran them against the runtime inside the oMLX bundle. It loaded in 15.7 seconds. It reported the architecture correctly. It generated 201 tokens in 7.5 seconds, 26.7 tokens a second. And it answered a technical question about gated DeltaNet attention correctly. No flags, no patched runtime, no trust remote code. The stock bundle, at the version that supposedly cannot run this, ran it, which means the compatibility test in the research I was handed fails in the expensive direction. It tells you no when the answer is yes. One thing before we finish. If you are building agent pipelines on your own, the hard part is not the code. It is having nobody to tell you that the thing you are certain about is wrong. That is what the school group is for. The free checklist and the mastermind are both linked below. So that is the practical question settled. Now, the interesting one. Every one of these builds leads with the same claim, and it is the claim you would use to decide whether the ablation actually worked, 0 refusals. Hub does the creditable thing again and publishes the measurement as a file rather than a sentence. And in that file, read the first line and the second line together. 0 of 100 harmful prompts produced an explicit refusal. 0 of 100 produced a completed answer. 100 out of 100 produced a completed answer. The test is named in the key that contains it, a 128 token refusal screen. Every generation stopped at 128 tokens. What was measured is whether the model started to refuse inside its first 128 tokens. What was not measured is whether it ever answered. And look at the control set. They also ran 100 harmless prompts. If the harmful numbers describe a model answering freely, the benign set should differ somewhere. It does not. It is identical on every field that matters. A control set exists to discriminate, and this one returns the same value on every axis, which tells you the axis is measuring the harness rather than the model. Now, this is not a gotcha I extracted. The same file carries the caveat in plain language. The token ceiling makes this an early refusal screen, not a full answer completion evaluation. The publisher was straight about it. The failure happens downstream, when the number travels into a recommendation and the sentence that says what it means does not travel with it. Widen the frame and it gets worse. The first two rows there are the same publisher describing the same weights on two different surfaces, and they disagree. A flat 0 on Hugging Face, a range topping out at 6% on Alama. The Alamar card is actually the more rigorous of the two. It names its test set. It distinguishes refusal from over-refusal, and it reports a range instead of a point. It is also the one nobody quotes. And the last row is a different ablation of the same base model, scored by an automated judge instead of a phrase list, coming in at 36 out of 100. None of these numbers can be compared with any of the others. No shared benchmark, no shared token budget, no shared definition of refusal, and in 2 of 4 cases, no published denominator at all. 2 practical things before you go and pull this. First, size your machine off peak memory, not disk size. The 6-bit build is 22.8 gigabytes on disk, and my run peaked at 26.3, and that was with essentially no context loaded. The publisher's own 4,000 token run peaked at 29.5. That is a 30% premium at 1.5% of the model's maximum context. Second, there is a third repository uploaded 3 days after the original, carrying the same card text and identical file counts folder for folder, with one difference: no drafter folder. The mirror reproduced all 4 quantizations and dropped the one component that made the original worth choosing. Check for it before you take any copy of either build. So here's what I would take away from this, and it generalizes well past one model. A dependency floor is a claim about a package index. It is not a claim about your machine. When a runtime vendors patches or backports, and every Mac native LM runtime does, the version string is downstream of the thing you actually care about. So ask for the capability by name. An array is a fraction. The fraction with an unexamined denominator is a decoration. 3 questions get most of it back, out of how many, measured by what instrument, and how long was the model allowed to run before you scored it. Every figure in this video and the commands that produce them are written up at abliterated.novicon.com. The full write-up has the hash comparisons, the runtime inspection, and the reproduction commands for all of it. If this was useful, subscribe to the channel and hit the like button. It genuinely helps these get found. Thanks for watching.